BitFlux technology consists of three main components: a service that sits inside your host that communicates directly with the Linux kernel to optimize memory usage, a model context protocol server, and a cloud API that glues them together. The best way to explain this is to show it. To start with, in the cloud we have a VM running the Ghost blog platform in an AWS EC2 instance that's managed by Terraform and Ansible. On my workstation, I have the excellent AMP AI agent from SourceGraph with access to Terraform and Ansible environments, plus the Grafana Labs K6 for benchmarking, and of course, the BitFlux MCP server. I start with an agent.md file to let the agent know what I want it to do and explain the environment to help it come up to speed quickly and accurately. First, AMP reads the agent.md file, does a sanity check, and reads the current state. Using Ansible, the agent installs the BitFlux eval service to collect metrics while we run a baseline workload benchmark against the original instance. Next, the agent uses K6 to run a benchmark to get a baseline performance score for the Ghost blog platform on the original instance. The agent then gets the custom system metrics from the instance using the BitFlux MCP server. Now, the agent uses the BitFlux MCP server to query the AWS API for instance types and pricing. It can use the system metrics from BitFlux and the instance type information to recommend a new instance type. Using the new recommended instance type, the agent uses Terraform to start over with a new BitFlux enable instance. This means it's using the BitFlux Ubuntu AMI from the Amazon Marketplace, which is a modified Ubuntu AMI with a custom Linux kernel and the BitFluxD service pre-configured. The agent pulls the system metrics from the BitFlux instance. Now it can compare metrics and benchmark scores against the baseline to confirm the BitFlux instance works the same as the original instance, just cheaper. We ask the agent to summarize the results in a report. It shows that the system started with a 2 GB instance and ended with a 1 GB BitFlux instance, which costs about half as much. The free memory in the new BitFlux instance is actually 2.5 times higher, even though it has less total memory, and the benchmark performance, if anything, is a bit better. In this demo, we've shown that using the BitFlux system, you can automate optimization workflows with AI agents, actively shrink the memory footprint your workload requires, better predict the memory requirements and costs of your workload, and reduce the costs of your EC2 instance by up to 50% without sacrificing performance. Try BitFlux today and reach out with any questions you have. Thank you.